Hey everybody, let's look at how Neo4j can parameterize queries. You see the presentation here under this short link. If you want to open it, I also have it in the links. Neo4j is always expecting this JSON object if you want to query or do anything with the database. It's one statements array with a JSON object that is always one single statement, a cipher query, plus a list of parameters, can be as long as you need, and the parameter key is always referenced in the cipher query. And as it's an array, you can really add how many statements that you want. I abstracted it in Unreal with this request object that is just a query enum plus these key value pairs, a string map that you can use here. So all the parameters would be strings in this string map, and then the query is one of the queries predefined in this enumeration. The enumeration holds queries that are kind of user readable, so to simplify it a bit, and of course to abstract it, because with the matching of the enumeration to a cipher query, you can easily exchange that to an SQL query or a Postgres SQL query or whatever. Meaning here would be the place to change it to a different database engine if you need at one point. The queries itself, they come from a string table to make it easily to manage. So we generate this array of request objects and iterate over it. First thing, as we saw, we want to map the enum to a real cipher statement. Then we have a look at the cipher statement, because a couple of them will have parameters, others not. If it has no parameters, you just add it to the final thing. For example, here the match n, return n has no parameters. The next one has the GUID as a parameter. If I don't have to do anything with parameters, I can just add it to this statement. If it has parameters, we have to iterate over the parameters, select the right parameters, and add it to the statement. The routine itself here is copied in Blueprint UI. It's more for an overview because it's missing a couple of objects in your code, so it will not run out of the box. But here you see how the matching of the parameters, how the creation of the JSON object and so on, how that works. Easier, of course, is if you just check out the project and leave it run in parallel on your computer. The GitHub link is always here in the comments. So the outcome of the whole thing will be a huge JSON object. Can be huge, depending on the number of queries that you can do. The number of queries is not really limited, but yeah, you should kind of split it out to not more than 1,000 per statement. Outcome is this here. You have this JSON object. It has always this array of different statements, this one here. So it starts with this statement array, and then as many statements that you need, comma separated, that are added to it. In our case, we will test around 100 of them, and that is exactly the JSON object that you will get. So looking at it, the statement itself here, the first one in the array, that is first cipher query. That's a simple one, creating or updating a node, and with a lot of parameters, because that's one of our periodic system elements with a lot of parameters here. And then of course we need the parameters. Here you have the key value pairs in the parameters list. And again, that is something that you then just add to it. In this case, we also want to have a relation between this element to be created, this new node, and a root node. So that is exactly the statement that we add here. So if we know there is a relation, then we look and match to the root it has and create a connection between them. And the connection here has a name. In this case, it's isElement. And yeah, type relationship, we put it in. That's kind of optional, but makes it easier to filter the results and be done. So what we see here is exactly this connection here. We have a root that is called items elements. We have an item, for example, argon here, and then we have a connection between the both of them, and we call that connection isElements because we can also filter on these connections and the names of them. What we want to achieve is kind of this scenario here. Actually, if you look at this hyperlink, then all the information of that tree here of that graph is within the hyperlink. So if you copy that URL, it's a very long one because all the information is encoded in here, and just paste it in your browser, you will see exactly in that long URL, you will see what exactly you get. Yeah? So we have a base structure here with a couple of root nodes, and we have a couple of examples for possible extensions to that. So let's look what we want to get. We want to have currency, we want to have elements, we want to have weapons here, all deriving from items and are childs of the items node. And we have inventories where a couple of different inventories are linked to. These are all base items. We want here to create the 5 root nodes and all the elements, that should be 99 of them, that we already have in the project. I have a small testing routine here where you just can select what kind of test should run. So for example, the value 0 should just give you database info. If you run it, it says, yeah, Neo4J kernel, so seems to be connected, no error, that looks good. But now let's try to do something productive. First thing, let's select all the nodes that are currently in the database, and we get nothing back, seems to be empty. And if we actually go to the database here running on localhost and say get all nodes, yeah, coming back empty, so the database at the moment is completely empty. Next thing is we want to store these base nodes, number 2. Let's look at the routine, what it actually does. A base node here is a small data structure based on this structure here with a GUID and a name as parameters. Then we have some label information, relations, we have a root name, and we have different properties. Properties I don't use at this point, might be an extension. Example here is the weapons base node. That should be here, the magenta one. And yeah, it has a GUID and a name. It has a couple of labels, items and weapons here, or item and weapons. And that is exactly what is here shown as a caption. That will be then a label where you, on what you can already filter or search for. So we have to make sure that we create a relationship here that should be is weapons, that is stated here. And of course the root name, to what graph node should that new node be connected to. Well, that is the information that we get from this data table, and we want to create all these nodes automatically with our routine, having these 5 inner nodes. And then in the next step, we can think about how to add more values to these nodes. Interesting also is here the root name. Without root name, we can leave that empty. Then it will be a singular, not connected node. Otherwise, we will have to fill that to get the relationship actually working. So let's try that out. We selected number 2 here and tried to store all the base nodes. So I would expect these 5 nodes being available. Looking into it, make it a bit bigger. First thing, we load the base node. That is simply loading the data table here with a kind of standard syntax. Only thing here is only you exchange what kind of data table the target is, and then it iterates around it, creates the struct that is the underlying base here, and returns an array. Then it fills the parameter map, because we have to break the struct and convert that struct into a string map. That is what happens here. So for each struct, you really would have to create that routine, breaking up the struct, and then adding all the different elements of the struct into a key value map of string. That is what happens here. Notable maybe, in some cases we have to do some work. For example, the GUID, we want to see if it's valid and we recreate it if not. The labels is an array, so we go through the array, iterate over it, and build the structure that Neo4j is expecting here. Let's open it. You see, you get this items, elements, hierarchical structure, and that is something that you would have to create here. So we convert the array to a string, and again adding that to the key value store. Here we create the request object, we add the parameters, we add the query that is needed. Then we check if it has a root. If it has a root node, we again create a request object, but in this case creating a Cypher query for a relationship and adding that. So iterating over that, it should create all these 5 nodes. Let's see. Oh, we are not getting anything back. Yeah, that's fine, because I did not define a return type here in the Cypher query. But if we go to the Neo4j and just get all nodes, you see, yeah, we actually have this item base node. We have a weapons base node, an elements base node, and a currency base node. And we have the inventories, that's a kind of singular node. So all the inner structure here is now created and can be filled with different other items. Yeah, let's try that for the elements, because we have this periodic system elements, 99 of them, that are already in a data structure. Here, of course, same thing. In this case, we load the elements. That is the DT elements table here that we can use for it. And these are items with a lot of properties. So let's map them properly and put them in here. Other logic, exactly the same, only that we specify another root node, this item elements as a root node. Yeah, and if I run that, yeah, you see here the routine is actually reporting what it added. So it should have added 99 of these elements, all connected to that one single node. Let's try that again. So we have to update that query, run it again, and looking good actually. So bigger here. Okay, as big as it goes. So these are, again, that is my currency, my weapon node. That is the items base node. But here we have the elements base node with this 99 different elements on it, with all the properties being set. You can define a lot of indexes, text indexes, and so on on Neo4j, so you can really speed up the discovery. And you can, of course, path through that tree if you want to know relations, that's the strength of the database, and how everything is related with everything. Good. So the creation of elements, that is something that we can do. We can give parameters, and now we have to work, of course, extending that structure with currencies, with weapon, with inventories. And these are then the base elements that we need, still the metadata that we need for our projects, for example. It's important to see these are in an inventory, these are only the base elements. So it's not really a club here, it's just a template for a club. Then I can start creating real clubs and daggers and elements and so on, linking them to that base element, linking them to an inventory, linking that inventory to a person, for example, or multiple persons. And that is where the graph begins to shine, because links between objects is where it's very, very easy to do. And that is one of the reasons that we selected that as the basis for an inventory. Thank you very much for listening. I will try to abstract it a bit more to make it easier usable. Other than that, you just can download the project. I hope it helps. Thank you.